Trigonometry. Chapter 1, Trigonometric Functions. Section 4, Using Definitions of Trigonometric Functions. Video 1, Reciprocal Identities. This series is based on content from Pearson's 12th edition by Lial, Hornsby, Schneider, and Daniels. One of the things about trig functions that makes them very useful in higher level math classes is the vast array of identities that connect them. In math, an identity is an equation that is always true, regardless of the values of any variables. For example, x squared minus y squared equals x plus y times x minus y is an identity. It's always true regardless of the values of x and y. In algebra, this is used to both factor a difference of squares and also to multiply a sum times a difference. In a sense, we've already discussed one type of identity. It was mentioned previously when discussing the definitions of trig functions. Recall the definitions of the 6 trig functions. Assuming theta is an angle in standard position, the point x comma y is on the terminal side of theta, and r equals the square root of x squared plus y squared, which calculated the distance from the origin to the point x comma y. The 6 trig functions are defined as follows. Sine of theta equals y over r, cosine of theta equals x over r, tangent of theta equals y over x, cosecant of theta is r over y, the reciprocal of sine, secant of theta is equal to r over x, the reciprocal of cosine, and cotangent of theta is equal to x over y, the reciprocal of tangent. Do you recall the relationships that were pointed out previously? And by previously, I mean like 10 seconds ago. The 6 trig functions occur in reciprocal pairs. Specifically, sine of theta and cosecant of theta are reciprocals, provided that y is not equal to 0. That would make cosecant undefined. Cosine of theta and secant of theta are reciprocals, provided x is not equal to 0. That would make secant undefined. And tangent of theta and cotangent of theta are reciprocals, provided both x is not equal to 0 and y is not equal to 0, because those would make one of the 2 trig functions undefined. Now, to capture all of these, we write the following reciprocal identities. For all angles theta for which the trig functions are defined, cosecant of theta equals 1 over sine theta, and sine theta equals 1 over cosecant theta. Secant of theta equals 1 over cosine of theta, and cosine of theta equals 1 over secant theta. Cotangent theta equals 1 over tangent theta, and tangent theta equals 1 over cotangent theta. You need to memorize these. They will never go away and will show up in future math classes, especially calculus, and especially trigonometry. Now, it looks like 6 equations, but the truth is it's only 3, and each one comes in 2 varieties. However, we can shrink it down to 3 equations. To show 2 non-zero expressions are reciprocals, you can also show that their product is equal to 1. So we could replace the top 2 with sine of theta times cosecant of theta is equal to 1, provided they're both defined. We can replace the middle 2 with cosine of theta times secant theta equals 1, provided they are both defined. And we can replace the bottom 2 with tangent theta times cotangent theta is equal to 1. So whether you choose to remember your reciprocal relationships, reciprocal identities, as products equal to 1, or as one trig function is the reciprocal of the other, you need to know all of them. Now you try. Pause the video and try the following problems, plural. I'll fix that one day. Fill in the blanks with the correct trig functions. All right, here's your fair warning if you haven't paused and tried the problems yet. Solutions in 3, 2, 1.